Now that I've got all of the keywords in, I just need to run the model and see what happens. So the easiest way to do that for me, at least, is just go to the File drop-down, Run LS-DYNA, and it will pull up the LS Run menu. So I click that, and up opens LS Run 2025 R1. I've been running a lot, so this is all pre-populated by other models I've been running. Yours may be blank. Here are the settings I have. I'm currently running on 4 CPUs, number of processors for the job 4, so I set it to that. I think by default it starts at 1. You can run it on 1 because it runs really, really fast, but that's what I have it set for. And I've currently got it set for double precision for some other models that I've been doing. Double precision is slower, but it's going to have higher accuracy. SMP single precision is going to actually be a lot faster, and for a model that's this simple, SMP single precision is going to be good enough. One of the other things that I do is down here, I toggle to start the LS-DYNA command window. Yours is probably like that. And what it's going to do is when I hit run, it's going to open up a command window that will give me text saying what's going on in the model. And I often watch that text scroll by, so I always like to open that up. And other than that, I don't think there's any other settings that I use. So what I do from this point, once this is all set, is I just hit the add job to the local queue, the play button, hit play. Because I've been running this, there's already results in my LS-DYNA directory, and I didn't change the location. So it's prompting me saying, do I want to override it? Yes. Yours may not say that if you haven't run it yet, but after you've run it once, if you rerun in the same directory, it'll do that. Now here is my window opening up, submitting the job, and now it's going to start scrolling by, telling me what is going on in the model. And there, it just flashed by. This is being run on a laptop, so it's not a very powerful machine, but it was still really pretty fast. If I scroll up, you can see here's what's going on with some of the cycle times and writing the plot files. It says it reached the termination time of 20 microseconds that we put in there for the termination time. It doesn't always. Sometimes it'll error, and you'll see instead of normal termination, it'll say error. It's got some information on how long it ran, how many cycles, total CPU time 5 seconds, and information like that. But it's done. I can hit any key and it will just get rid of this window. And now I want to look at the model. So that can be done here by clicking on pre-post. That's a pre-post button that will add in the files that it has saved with the plot information. You can also just open up another pre-post window and open up the D3 plot file. So here is our TNT again, and now I've got a play button and animate, and if I hit play, you can see, oh, it's expanding. It's kind of, well, what we think a detonation would do. You can change the animation speed over here to go slower or faster. So let me set it to, maybe that's a little too fast. Let's try that. I'll go a little slower. So you can see that it's blowing up, and it's just showing the material expanding, which really isn't very interesting beyond the fact that it's detonating. So it would be nice to look at some kind of pressure or velocity or something like that. So let's do that now by going over here to the post button. And if you don't have your text under it, then you just have to go over here to the view toolbars and text icon right, text icon bottom. It'll add it if you want that. But let me go hit post. Now I've got the post options, and the two main ones that I use here. This right here allows me to select a particular variable to plot. And if I need to, this allows me to change the range of the variable. But usually it's here, so I'm going to click that guy. And here are some of the values that I can do at the moment. X stress, Y stress, Z stress, X, Y, but here's pressure. Let's just look at pressure. Pressure is just a simple scalar. And if I look at pressure, there, it's nicely colored. Here is my pressure bar over here saying, okay, what is the range? Dark blue being 0. Up here, red is 20.99 or 0.2099. If you remember, the CJ pressure for this particular problem was, I think, 0.21. Let me just double check quickly. Yeah, it's 0.21. So you can see we're actually hitting the CJ pressure right there. So that's the peak pressure. If I hit play, you can see it sort of evolve as it moves down. Uh, One of the things that I want to point out and note is note how on the right-hand side we have expansion gases coming out. That's the way we expect it to go. The left-hand side is not expanding, and that's because this is an axisymmetric model. So this would be the center of a cylinder, which is not going to expand. And so that was because we picked that shell element form 15 to be axisymmetric. Here in a minute, I will change it to something different and we'll rerun. Let's look at something else. Maybe we want to look at velocities instead. So this is, if you click on these, you can get different options. If I click here, then I can look at the result of velocity, for example. And this is telling me how fast the various components are going. And you can see that we've got a high velocity on the outside of the gases as they're expanding out. This is going to be 0.46 centimeters per microsecond. That's going to be in meters per second, 4,600 meters per second, I believe. So it's really, really expanding rapidly, and then it's tapering off, and it goes to pretty much zero at the center because it can't expand this way or any other way. So it's kind of behaving the way we would expect. Now, as I said, this is an axisymmetric geometry. Let's go back and try to change it to a just an XY geometry where this is no longer the center of a cylinder, but it's just the left X edge and the right X edge, and then we would hopefully see it symmetrically expand. So let me just click out of that, and I'm going to close that out. And if you remember, that was under shell. So let me go here. I'm going to change shell element form to 13. So I'm going to use the plane strain form. So let me change 13, accept, done. I need to save that, save my keyword, and then rerun. Run LS-DYNA, and then play. I need to overwrite my files, and it should take just a second here to start up. And it is done. So same thing, let me open up my LS pre-post. Click here, and let's hit play and see if it looks different. And sure enough, it does. Look, it's no longer bound at the center. It's expanding left and right. If I pause it, go back some, and let's turn on pressure. Let's see what the pressure looks like here. Now we have a center pressure, and it's actually a little bit lower because it's just expanding out of both sides. It hasn't reached its full CJ pressure yet. If you actually watch a detonation as it starts to propagate down, it takes a little bit to reach it. So it's a little low. It's 0.15 instead of 0.21. Let's go a few more. Let's see if it gets stronger. Yeah, you can, well, actually, let me back up just a little bit. You can see that it is 0.156 getting a little bit stronger. 1.6, 1.6. So if I had a much longer one, it would probably finally reach CJ pressure. A couple of things if you want to do, if you want to move this around, you have to hold the shift key. If you hold the shift key, left mouse, it'll rotate, allow you to spin it about. Because it's 2D axisymmetric, it doesn't really make sense to spin too much. If you center mouse, it'll let you drag it, shift center mouse, drag it around, and then shift and right mouse button zoom in and out, but also shift and the scroll will do the same thing. So with that, we've now run a simple TNT model that we blew up. We blew it up in axisymmetric form, and we also blew it up in just Cartesian form. So hopefully that gets you some ideas on how to play around and maybe try some different things.